Welcome everyone. I'm Carlo. I don't know if you ever hear about confidential computing. It's an argument that triggered me in the last month, and I think it's a good thing to know because it's a part of cybersecurity, and everyone now in these years, as every customer is taking care about that. So it's the next steps to do cybersecurity. So just a little brief about me. I'm an IT engineer, so I work in IT just when I go out to school, starting from the server under the CEO desk, then approaching VM, cloud, etc., etc. So the technology is don't know we are going, but okay, we must follow the technology. Sometimes we can do it, and now, of course, I used to be a sysadmin. Now is a DevOps, a cloud architect. I don't know what's the shape of the name now. We can describe us, but let's continue. It's my first speech, so. Literally outside the growth zone for me is I'm honored and excited to be here. So I hope everything will be clear, and if you are if it's something that is not clear, feel free to ask what is not clear. Okay, just a short agenda is we will talk about what is confidential computing, the key concept. It's not an easy argument. It's very technical sometimes. There are some concepts that are very go deep in the technical mechanism. Shut up. So at the end, I will show you some link where I read the documentation and see YouTube, etc. to make this presentation. So. If you want to go deeper, I will send you some documents and some useful links if you like it. So, of course, we will talk about confidential computing on Azure, how Azure implements confidential computing. We'll talk about the Consortium. It's not a technology owned by Azure, but there is something global that is growing with other partners over the other players. We talk about the cost, little spoiler, cost more, so okay, we can close this point, and just to see some customer in the market that expect to be in the next year. Okay, let's start. I think everybody knows what is the power of the cloud platform. So what's the facilities that bring to our work, the new opportunities, etc. But there is a very big problem, a very big answer that question that some customers, for many reasons, are asking to the player or to the because they want to know if their data are very safe where they put the data in this platform, Azure, but can be something else. Because they want to have the fully control of the data, of the life of the data, starting from the one they generate to the destroyed. And for many reasons, maybe there are privacy rules or regulation compliance of government, of local government that are more strict sometimes, because maybe I don't trust, or some customers don't trust to put the data on the cloud, simple, or maybe we know that the cloud and this technology bring the possibilities to collaborate, because we can put all the data in one place, not in one place, but one big basket, and we can make data works together. But the data comes from different customers, and the customers don't trust each other. Confidential computing bring the way and to do this. So this is the typical This is a typical box where we customer has in the cloud platform, so he has he can do operation, then put the data, can make everything he wants, build infrastructure, database, etc., make operation, etc. But around this environment, around this box, around this garden, there are many actors that can go and can see our data, you know, because our data is just like a file, just a virtual machine, but around there are actors, there are many layers that could be have access to our data, and they are there to keep the platform up and running for the daily operation, so we can remove them. Okay, so they must be there. We have some technologies to protect our data. We have data at rest and data in transit, so we can protect the data by encryption when they are stored, and by encryption when we are transport the data to the cloud. But there is another stage that is called the data in use, and when the data are being processed while or just read, we know that if we use the encryption in a certain time, that that data will be clear, so in the RAM on some cache, you know. So confidential computing brings this possibility to encrypt the data in memory. Okay. Just a little story. You know Meltdown Spectre vulnerabilities. They was able to see and catch the data while they was processing. So while the data was processing. So this is a solution for that. Sorry?
Which vulnerability? You mentioned
Meltdown Spectre. You know that the bug of 2018 that from the evening to the morning we had to patch every hypervisor.
I remember, yes.
There was they had the capabilities to read the data while they was processing. So in the RAM, and there was a really bad vulnerabilities. So Azure, the confidential computing in Azure, what means the hardware root of trust. I will explain you what it is. A customer verify remote attestation. This is another part of the confidential computing. This is very technical. I will describe you as simple as I can, but it's just like a registry that where a customer can check what he want, and in the same how he want, and if everything is matching the desired state, the confidential computing can start. Of course, the memory encryption, because it's the basis of the confidential computing. What are the benefits? Of course, the memory encryption means that all the data are encrypted during all the lifetime of the life cycle. It reduces the chain of trust. So the chain of trust means when I put the data in the cloud, I have to trust someone else. That could be Azure or other place. It reduces the chain of trust, the root of trust, till only myself, like a psychological question. I have to trust only myself, because my code will only be the part of the application that can read the data and nothing else. Outside there is nobody that can read the data. And of course, this brings the possibility to share the data, because if I and you, we agree about an algorithm, and we put our data in that algorithm, and the process can elaborate our data, but I don't know what you put in that, and you don't know what my data, and the algorithm will answer for with our output and so on. So everybody is safe. So the definition is what is confidential computing is the protection of the data in use by performing computation in a hardware-based trusted execution environment. The TEE is the first key concept in the confidential computing. What it is the TEE or enclave? I don't know, the enclave in Italian means where the Pope is election. So it's literally a room where nobody knows what happens. It's better don't know. But we know when the Pope is is elected or not with the white or black smoke. Okay, for us can be the output of the process, But the enclave can see it like this. Where I was, okay. Okay, so this is the definition of confidential computing. Let's go directly to a couple of scenarios that confidential computing is implemented in Azure. This is a typical stack of the platform where we have we have an application that may be running the operating system, and this can be our virtual machine, and then there is a hypervisor, etc., etc. This could be a container too, and let's see that it is working of Kubernetes. Our app needs to do a safe computation and ask for the confidential computing, okay, and must ask to enter in the T, because the T is literally a box. It's a separated environment, trusted, hardware-based trusted, where only there where only there the computation can happen, okay, not outside, and that enclave is completely full, is completely encrypted for the external, so nobody can read that. The app asks to enter in the T. The T is trusted by hardware. There are completely new products from Intel or AMD or ARM or NVIDIA that they build a completely new architecture of a CPU, a chipset that is mounted directly on the hardware of the physical server inside the data center. So when the app wants to go inside the TE, he receives like a trust from the hardware, and the T's can go on. So this is the first scenario where only a partition of the app that must be written for the TE must be written from TE. The other scenario is that the app is good. I have to write my app, but I can use an entire VM and put that VM directly to the TE. Okay, so and is the solution of AMD. AMD processor as the solution for the too much. Okay. Has the capabilities to bring all the entire VM inside the TE. Is going? Okay. What's the difference? The difference is that we have to trust the OS of the VM, and so is a bit less of trust because there is other actors. But we can customize our Linux distribution and make it safe and lift and shift directly to our environment, to our TE, and so return to the first steps as not only the application, but I have the entire virtual machine, but the virtual machine is completely customized by me. So I'm trust myself, I know that everything is good. So this is the typical scenario, where on the left we have Intel with the app that must be partitioned. So maybe we can have an app with the trusted partition with the trusted, and another app untrusted. So only the trusted app partition of the app can enter in the T, or the virtual machine. Okay, so this is a typical scenario. They are implementing other things like Kubernetes, etc., like serverless containers, or etc. And everything is new. So literally, some services are in general available, but other are just right now. It's a limited preview. So it's something that is born in 2018, 2019. So literally, is a baby for us as a technology. So this is the 5K fundamentals of the TE and the confidential computing. So the other root of trust, the remote attestation. The attestation is how can I? It's possible to do remote attestation. So the customer can now can know if the order is okay. Verify if the environment is exactly the way it is expected to be, and this is done before the TE, the spin up of the TE. So it's like a registry. I show you after like a bit how it works. We have a trusted launch, so directly from the boot of the virtual machine and the boot of the TE. We can go deep. We can go deep, literally from the boot, and check if everything is okay. If something is wrong, or there is if something is tempered, or there is a rootkit somewhere, is the TE don't the attestation don't validate the sequence and don't spin up the TE. Of course, we have the memory isolation encryption. This is basic. And of course, every step is done with a K. Okay, the K2 is a process that runs in confidential computing and for trust everything. Remote attestation is done in a confidential computing too, as confidential computing too. So it's like an attestation of itself. So if something is not in confidential computing, it can be confidential. Okay. So to be more clear, I don't know if you know this picture, the pizza as a service. We can compare this with the trust that we want in our system, but at the opposite. So more trust we want, less we have to, more we have to do to write. Less trust we want, we can for example here we don't trust, we can go like in and out. So this is a schema. We have a typical VM, okay, where outside that can be viewed by data center army, hypervisor, etc., etc. We go up with encryption and confidential. So here we have the virtual machine, confidential computing virtual machine, where we have only the VM admin that can be that can we trust, or that, or in the top we have only the application. So the application, the partition of the application. So only a part of the application is trusted, and it means that I have only trust my application, or the operating system is outside my box. So this is the level to be just a little more clear. The attestation, as I said, is a bit complicated, but let's see like a sort of cryptographic registry, process registry. I used to do an example like this. I need a loan. I go to the bank. I ask to the bank if I need the loan, and the bank check all the database. If I'm criminal, if I have a loan, if I can pay the loan, etc. The bank answer to me, okay, you can have the loan, or I can give you the loan. So I'm here, I'm the tester that I ask the loan to the bank. The bank check all the database inside. This is the attestation service, and answer to me, you are okay. This is the simple way to describe the attestation. In fact, is more complicated. Inside there are key exchange. The key exchange two are made in a cryptographic way. So to run the enclave, to run the T, there is an exchange of key with the customer, and only when the customer and the attestation say okay, all the registry, all the program that must run inside my enclave are okay, I give you the key in a cryptographic tool, and inside the enclave I can decrypt the key to run the enclave, to run my TE. Okay, so it's a sort of like a VPN where we send the key, and only the destination can access to the key to decrypt the key to run the enclave. So this is the simple way. There are two models that is called passport or background check. This is the background check. The other is called a passport, and you can imagine that the verifier is not here, but is connected to the tester. So the tester asks to the verifier, so that directly to the attestation service for us, if it's good and can run inside can spin up the T, and if everything is good and everything is checked as good, they can spin up the T and go on. Quickly, the confidential computing consortium, as I told you, is not an Azure products, let's say something like this, but there is a consortium that is driving and literally is writing these months documentation and for the certification and how I don't remember the names. Oh, sorry. How the way to do the attestation and confidential computing tool. So Microsoft with Azure is one of the key foundation of the consortium, and the idea of the consortium is to bring the attestation service outside the cloud platform and the player, because now in the Azure we have Azure attestation service, and every player has an own attestation service. But
is it a separate service or it's within the confidential computing?
No, it's literally within the confidential computing.
Okay, it is. Okay, check.
Yeah. There is Azure attestation service. Is a name. Is a product of Microsoft in Azure. But the idea is to use like a blockchain to move outside this service and reduce again the trustiness of the attestation, because now we have to trust the attestation service of Microsoft, but in this way it could be provider agnostic and using the blockchain algorithm, etc. The idea is to move there. Okay.
He's a blockchain developer.
Okay, you know, I think you can explain better. But the idea is that we don't need to use the attestation, the Azure attestation service, but will be completely decentralized. These are the service in Azure that with general availability you can see inside the console or limited preview. I don't see it in my console. I don't know. I'm a normal user. Maybe an insider, a Microsoft Insider has. I don't know. But there are quite the 80% of the service that we daily use. So we have SQL. Okay, we have this is the
virtual desktop.
Yes, they announced 1 month ago. So we have Windows 11 in confidential computing in our in Azure platform. As you see, we have a confidential computer attestation. The managed HSM is the service to manage the key inside for the confidential computing. We have Kubernetes and container services too, and of course virtual machine with this DCA, ACA. The C stands for confidential. If you see the naming of the type of the virtual machine, you can see the name directly. There is NVIDIA too, because they are trying to with the GPU to make AI, ML process better, and you can see this. Some customers are Signal. I don't know if you know Signal, that say we are completely no government can send. They use the confidential computing in Azure. So because they say that if a government go to Azure, go to Microsoft, and they ask for our data, for my data that is confidential computing, they say, I can't give you the data of Carlo because I don't have the key. Carlo has the key, but nobody has the key. Only Carlo can give you. So this is the main what do they say? Firebox is a blockchain aggregator, like a bank, etc. And these are 5 other customers. This is a price comparison with we have a standard D2. This is not confidential, but this is confidential. Sometimes it's double, sometimes it's less than double, but of course cost more than a single standard VM or a normal VM not confidential. This is the EC2, so we are optimizing in memory, etc. So there are this kind of machine. Sometimes there is not available. As I said, they are bringing in this month. They are growing this month. So
not all SKUs.
no, depends by the region, depends by the virtual machine, the sizing, etc. So maybe you don't have this. They are not available in other region, but they, of course, US Virginia is the first that usually you can see. So a short recap: what is confidential compute is means to have now the fully control of data lifecycle. Okay, as I told you. So we have the encryption and the possibility to encrypt the data in memory too. So now there is not a single moment when a data is in clear mode, is clear. Okay. The cloud platform provides an outside cluster computer base, because now we don't have to trust Azure or cloud platform. We are like in our box that can be everywhere, but outside our box nobody can read it. Code running in the cloud is protected and verified by the customer, as I told you now. And okay, the activity history is immutable and auditable. You can go deeper with the history and stop and not inspect.
Basically, as I read this can also be used as a proof of a criminal case in the forensics.
Yeah. But if they can have access to the data, but they don't have access to the data.
Yeah, but you need to give the.
Yeah. Okay. And this is how expected to the confidential computing market grow. So I don't know if it's real or not. I have this data from the head of confidential computing in Microsoft. There is a webinar. I give you the link after. And they expected to a very strong grow about that. So maybe that's why it's good to know that there is the possibilities too. This is the link. Oops. Oh. Okay. This is the link. Ariel. Okay. If you want to scan the QR code, I collect all the link, the useful link. Don't see about the graphic design this website because I'm not a web developer. And that's all. Thank you for if you have some question.